Hi, everybody. In this video, we're going to be talking about Unit 4.2.1, which is understanding proportions. So like normal, we are going to start first with our definition. A true proportion is an equation that states that two ratios are equal. Proportions can be used to solve problems such as increasing a recipe or decreasing it, to feed a larger crowd of people, or enlarging or reducing an image to scale. So even like a true proportion is an equation that states that two ratios are equal. So something like if we had like 4/8, that's the same as 1/2. And the 1/2 is the same as 50 over 100, or 21 over 42. All of those are true proportions because we've got all of those that are proportions that are equivalent to one another, or they're fractions that would all reduce to 1/2. I'm hoping that some of this is starting to kind of click and make lots of connections for you because of what we were talking about last week with comparing fractions. You can absolutely apply it here to our discussion on proportions. So here's a few different ways for you to identify true proportions. So how would we figure out that a proportion is a true proportion or not? Like, how do we make sure that our fractions essentially are equivalent? Well, one, we can make sure that the units in the individual ratios are consistent, either vertically or horizontally. So for example, if I have 45 miles per 1 hour, that is the same, a true proportion would be like 135 miles per 3 hours. But we could also write it like this. We could also say, or we could write it as 45 miles per 135 miles. And again, I did miles to miles. So there's my unit that's consistent vertically. And here my unit is consistent horizontally. And I did simplified to not simplified, simplified to not simplified. And so here it would be 45 miles to 135 miles. And then you would say 1 hour to 3 hours. We could also do it. I mean, there's another way you could write it up too. I'm kind of running out of space here. But what you don't want to do, like you don't want to write it as like something like this would not work. So if you were doing like 45 miles per 3 hours, and then we did 1 hour, and then I'm going to do, what was the last one? 135 miles. So that would not be true. That is not going to be a true proportion, because if you reduced this 45 over 3, you're going to end up getting 15 miles per 1 hour. And that's not at all what this says. So you just have to be careful there, making sure you're lining things up appropriately. So that one is not correct. All right, so here we can express each ratio as a simplified fraction. If the simplified fractions are the same, the proportion is true. If the fractions are different, the proportion is false. So that's just the same as when we were talking about comparing fractions last week. That's the same method. Or we can check to make sure that the units in the individual ratios are consistent. So same thing, first make sure that your labels and units are consistent either vertically or horizontally. And then you can use cross multiplication. I'll move this up. You can use cross multiplication between the two ratios. If the products, again, product is the answer to a multiplication problem. So if you need to write yourself a note there, product is the answer to a multiplication problem. If the products are equal, then the proportion is true. If the products are not equal, the proportion is false. So let's check this one out. So this one, you can do it lots of ways. You can say, well, I'm going to reduce them and see what I get. So you could reduce them, and you could take out like an 8 here and an 8 here, and then we would end up with 3/5 over here. And then maybe we take out, looks like this is divisible by 13, and this would be divisible by 13, and we would end up with 3/5 again. So is this proportion true or false? This proportion is true. Or if figuring it out like that is a little bit trickier for you, then do cross multiplication. Do 39 over 65 equals 24 over 40. And instead we're going to cross multiply. So I'm going to take my calculator and I'm going to do 39 times 40. So 39 times 40 gives me 1560 or 1,560. And then I'm checking to see, well, is that what this is going to equal to, the product of that? So 65 times 24 also gives me 1,560. So check. This one is a true proportion. So let's check another one. It says, is the proportion true or false? So first of all, and by the way, if we looked at this one had no label. There were no units on it. So the units, we just assume that they are trivial, they are going to be consistent. And then on this one, is the proportion true or false? Well, let's first check our labels. Looks like they're consistent horizontally. So we can go ahead and try that. And then you might say, okay, well, it kind of looks like they might be a 4-to-1 ounces per serving. So like if I divided this by 10 and this by 10, I'm going to get 4 ounces per 1 serving. And then if I divided this by 21 and this by 21, I get the same thing. I'm going to get 4 ounces per 1 serving. But if you didn't see it like that, if you were like, whoa, 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 what just happened? Then do your cross multiplication instead. Do some cross multiplication. And so the first one would be 40 times 21. Does that in fact equal 10 times 84? And let's check it. So 40 times 21 should give you 840. 10 times 84, that's just going to move your decimal over 1, which is going to give you 840. And so check. So this is a true proportion. Check. This one's true over here as well. All right, so let's check number 3. Number 3, it says one office has 3 printers per 18 computers. Another office has 20 printers. And again, I'm making sure I'm putting them consistently in order. So printers are going across horizontally per 105 computers. Is the ratio of printers to computers the same in these 2 offices? Well, let's check. One thing I'm noticing, by the way, like what my brain just kind of looked at, is the fact that 3 over 18 would reduce to 1/6. 20 over 105 is not going to be 1/6. It's going to be like 20 over 100 would be 1/5. And then 20 over 105 is going to be a little bit bigger, or sorry, a little bit smaller. So it's not going to be 1/5, but it's be close to 1/6, but not exactly. So it's already not true. But I don't want to write all that reasoning out. I'd rather just show in numbers. So I'm going to go ahead and just cross multiply. And I'm going to say 18 times 20, does that in fact equal 105 times 3? And so here you can put it in your calculator if you'd like, or you can just, what's 18 times 2? That's 36, and then a 0. And then for my brain, I'm thinking about 3 times 100 is 300. 3 times 5 is 15. So that gives me 315. And so what that says is that those two are not equal. This is a false proportion here. So is the ratio of printers to computers the same in these two offices? No, not the same. All right, let's check out the next page. So our next page says, if you know that the relationship between two quantities is proportional, you can use proportions to find the missing quantity. Okay, so this one is kind of saying, so before we were checking to see, are they proportional? So they're giving you, two different proportions and they're saying, are these proportional? Is this a true proportion or not? Now what this page is having us say, it's saying, I'm telling you that these two proportions are proportional. Now I want you to solve for the unknown, solve for the missing piece. So here you can you can say, well, it looks like in order to get 4, I divided by 5. So if I divide this by 5, I'm going to get 5. And so my answer here would be n equals 5. Well, you can also cross multiply. So we could do 20 times n equals 25 times 4. And then that would give us 20n equals 100. Divide both sides by 20, and n is going to equal 5 for that. So either way, just make sure you show your work. So here's where we were talking about doing proportions of a picture, right? So it says, find the length of a photograph whose width is 12.5 inches. So I'm going to do width versus length in my proportions. So it says, find the length. So mine is going to be, find the length of a photograph whose width is 12.5 inches and whose proportions are the same as a photograph whose width is 5 inches. So again, I got to be careful. 5 inches goes on top because that's the width, and whose length is 8 inches. And so how do I figure this out? Well, I'm going to go ahead and cross multiply. I'm going to do 12.5 times 8, and that equals 5L. So 12.5 times 8, that gives me exactly 100. So 100 equals 5L, and this should look really familiar to numbers we used just above. Divide both sides by 5, and our length is going to equal 20 inches for that. All right, let's talk about number 3. It takes Sandra 1 hour, so I'm going to write this down, 1 hour to type 4 pages. At this rate, how long will she take? So how long, that's how much time. How long will it take her to complete 27 pages? Well, I'm going to go ahead and cross multiply again. So I'm going to cross multiply. And I get 4x equals 27. Now divide both sides by 4. And I'm going to get x equals, and you can put this in your calculator. You can say, well, how many times is 4 going to go into 27 evenly? So it's looking like it would go into it evenly 6 times, because 6 times 4 is 24 with 3 left over. So 6 with 3 left over. Then I have to remember, what does this even represent? X is the number of hours. So it's going to be 6 3/4 hours for her to do the 27 pages. Or if you wanted to, you could be super fancy and you would be that 6 hours and 45 minutes, because 45 minutes is 3/4 of an hour. Okay. Number 4, a map uses a scale where 2 inches represents 17 miles. If the distance between cities is shown on a map as 20 inches, how many miles apart are the 2 cities? So that's our question. Here, it kind of looks like we could do this pretty easily, because we can look from left to right. We could say, oh, 2 times 10 gives me 20. Or you could do 17 times 10, and that's going to give you 170. So 170 miles is your answer. If you didn't see that though, you're absolutely welcome to cross multiply. You can cross multiply here and here, and we would get 2x equals 17 times 20. And then we would get 2x equals 3,400. Then we would divide both sides by 2, and x is going to equal 170 miles. So either way, whichever way you chose, it's totally fine to do. Just pick one, make sure you show all your steps and circle or box your answer, and you're done. And we're done with this video. So thanks for tuning in.